Okay, so in the previous videos, we learned how to calculate the variance and how to calculate the standard deviation. So I spent more time on its algebraic definition and how to calculate, like the mechanical algebra methods to calculate them. But I didn't talk much about the meaning. So of course, the basic meaning is pretty intuitive. The larger the standard deviation is, the more variable the data are. So it's a measure of variability. Both the variance and the standard deviation are measures of variability. So they have the same interpretation like this. But what does like a number for like a specific number means? Like for example, if you find the standard deviation was 10 for a specific data, what does it mean? So standard deviation is 10. Then what is it? My answer is there is no meaning. It's more like a unit. It's a unit rather than something else. Like for example, what I'm saying here is, say, here, come back to this example. The mean is 6, so remember, it's a gain or loss. I said minus $10 plus $20. So they had units. And then, when we calculate the expectation, automatically you can call this $6. It shares the same unit as the original outcome. $6, $5, $60. But variance does not have that same unit because it's not consistent. Like if everything is $10 10 times increased, but the variance increased by 100 times, so it's not a dollar anymore. But when you have standard deviation, you may say that standard deviation is $12. $12, $120. So the unit becomes the original unit. However, still it has no meaning. So $6 can be interpreted intuitively, but standard deviation $12 cannot be interpreted, I think. I think it's like asking these questions. So, what does 1 inch mean? So, like my height is like say 67 inches tall, but then what is 1 inch? Like, or what does $1 mean? I have say $10. Then what does it mean? How rich I am? Or what is 1 degree in Fahrenheit mean? Of course, in their origination, originally they had some meaning. Maybe 1 inch was something like this, like I don't know, and $1 was converted into a certain ounces of gold in the past, right? However, like and degree Fahrenheit measure must have some scientific definition, but we don't need to know them. In practice, when I say 1 inch, 2 inches, $1, $2, I don't know. Even if I don't know how they were defined at the beginning, still does not matter. In our applications, it is just a unit. It just provides a unit, but like without specific meaning. Just if you get used to it, so it's just a means of comparison. Like that's a more better way to describe the meaning of a standard deviation. So think about this example. So standard deviation provides units for data with different variability, for example. So for example, I'm going to consider the case of, say, Academic Excellence Award. So again, at the beginning of chapter 3, I gave you an example like this. You are a professor and you have to choose one student who is going to win the Academic Excellence Award. But, or say, admission. student who is going to get an admission. So student 1 has a GPA of 3.4 and student 2 has a GMAT score of 600. So this is a problem because the first student has a GPA and like unit is like at the maximum of 4, and student 2 has a GMAT score which looks like 20 times larger, but you cannot say GMAT score is 20 times larger. They are not comparable, right? So this is the problem with different units. The units for GPA and GMAT have different scales. And then what you can do here is, first, you may compare their scores to their respective average. For example, suppose that the average GPA is 3.15 and the average GMAT score is 560, for example. I don't know if it's actual average or not, just an assumption. And then what you can tell here is whether each of the students is above or below the average. If one was above and the other was below, then the decision is simple. Then you are going to choose the one above the average, right? However, in this case, both of the students are above average. And again, the scales, the units are still different, right? 0.25 and 40. What you are doing here is, okay, you learned both students are above the average. Now, your decision is to find, your decision is to determine who is more above, who is further from the average, right? The distance from the average is larger than the other. Then that student is better, right? It's more about now distance. So when you need to compare distance from the average like this, then standard deviation can play the role of the unit. Like for example, additionally assume that the standard deviation of GPA is 0.2 and standard deviation of GMAT is 30. Still, you see the scale difference, right? And then now you may standardize the scores this way. So the first student had a GPA 3.4 and average GPA was 3.15, which is 1.25 standard deviation above average. You may think like it's like inches, 1.25 inches above the center, something like that. So it's like a unit. And the second student is 1.33 standard deviation above average. So standard deviation itself is a unit that measures the distance of an realization, right? So if you take this as a standardized score, then you can choose student 2 is better, have a higher score, right? We are going to call this standardized score or Z-score. You may have heard about this. Later, you are going to see this kind of standardization a lot. We are going to use it a lot later. So here I'm just explaining the role of how you use the standard deviation, and in conclusion, there is no direct meaning in standard deviation. It is like kind of, the definition of standard deviation has like nothing to do with its interpretation, right? When you interpret, it's more like a unit. So anyhow, in the end, we have a standardization. So when you have an observation X, what you're going to do is subtract the mean so that we can tell how far X is from the mean, and then divide it by the standard deviation. So then you can standardize the distance of that observation from the center. So I am going to define z as a new random variable, which is a standardization of x, right? You can think it as another transformation of random variable, right? And you may use this as a measure of relative standing. So in an earlier chapter, we learned another measure of relative standing. That was percentile. So when I tell you you are 90 percentile, that means you are top 10%. So it tells you how good you are, like from say test, right? But similar role, like the same thing can be done by calculating the standard deviation. Excuse me, by calculating the standardized test score, right? By calculating the z-score, if I say your z-score is +2, that means you are pretty, you did pretty well. So also all these things will like come up later again. So just like now later you are going to connect everything, and you will realize why I explained it here. Okay, so this is actually the end of the measure of variability. So I have explained the main part of the chapter, and the last several chapters, last several pages will be about more minor measures, like this measure of asymmetry. So it's an extension of measure of variability. So think about this. Variance is defined this way: deviation squared. And then mathematically you may generalize it to the exponent of 3 cube deviations. So we call that skewness, because this measure, by taking expectation, if you take an expectation, so mean of these cubed deviations captures where the outliers are, where the long tails are, right? So have a look at this. So if you think about distribution like this, the outliers are here. Tail is long on the left side, and we call this left skewed, negatively skewed, or left tail is long. And also you can find mean is smaller than the median. But overall, the best measure is to calculate this skewness, and you will find skewness will be negative. Then it means that outliers are on the left tail. Of course, if you flip the image, then outliers are on the right side. Right, we call this right skewed, positively skewed, and like right tail is long. Mean is greater than the median, but more formal definition is based on skewness measure, because it is a measure of asymmetry. So as you see, there is a pattern. You may increase this number to 4, 5, and more. So there are names for higher order measures, but not much important. Most cases, like mean and variance are enough. But additionally, sometimes if outliers are your concerns, then skewness may also help. And another topic given in many textbooks, but I don't cover, is the mode. Mode is defined to be the most frequently occurring value. So that's the definition. So almost all textbooks explain mode as a measure of central location. It's not wrong, but I have never seen mode as a central measure in practice. So in applications, mode is not at the same like importance as like median or the mean. So I do not explain mode that much, but it is more often used to describe the peak of the distribution. Have a look at this. So mode is where the histogram is highest, the peak of the histogram. Here is the mode, here is the mode, here is the mode. And these three distributions have, each of them has only one mode, only one peak. Peaked peaked at one point, so we call that unimodal. They have only one mode. But in this case, as you see, mode is here. Here is a peak, but then another. So there are two peaks, and we call them bimodal. You have heard about this, bipolarization. So it's like there is one peak, another peak. So the shape of this distribution is called bimodal because there are two modes. Two modes exist. And if you have multiple modes, multiple peaks, then you can call multimodal. Of course, multimodal distributions are rare, as hard to find in practice. And finally, this is a special case where there is no peak. It's just flat. In this case, we call this distribution as the uniform distribution. Equally likely. Everything is equally likely, like a dice, right? So this is an example of how we use mode. Like so, I think this is a more common usage of mode rather than as a measure of center. So that's why I set aside mode like this. Okay, thank you for watching. Chapter 4 is finished. So in the next chapter, we are going to start a new part. So it will become actually much more difficult. So, have a nice week and see you next time. Bye.